to do this example. Okay, so I will solve this this question in front of you so that you can see what kind of strategy that we can use in order to solve this kind of situation-based problem. Okay, because this kind of question will also be appearing in your final exam, where you have to come up with your design based on the requirement. Okay, so let's pay your attention to this example. So you can see this is the example for a two-way pneumatic conveyor. Okay, so the first thing you have to do is, of course, to read the question very carefully and try to highlight any important requirement that you have to have in your design. So okay, let's just read this together. You have this figure shows a two-way pneumatic conveyor. So you know that this is a pneumatic system because it can be hydraulic, it can be pneumatic. But in this case, it mentioned pneumatic. So you know that this is pneumatic. So you should use all the symbols related to pneumatic, especially in terms of the power source. So we don't expect you to use pump in this case. Then your design will be totally wrong because it's already mentioned here it's a pneumatic conveyor. Okay, and then transfer components to the test station. So you can see on figure here, the test station is here, down here to the left. Okay, via a bridge. So you have the bridge like this. Okay. So the cylinder will normally be in extended condition. Okay, this is also important. So this statement shows you what should be the original position of the cylinder. So in this case, the cylinder should be in extended condition originally. Okay, or in this case, they mention it as bridge up. So it should be just like in the drawing here. So you can see that the cylinder is in the extending mode. So the bridge is connecting the input conveyor to the test station. Okay, next, continue reading. When a component is to be transferred, tak kisahlah, maybe any electronics component or any box, okay, you need to transfer the component from the, okay, when when a component is to be transferred to the lower output conveyor. Maksudnya lower output conveyor is down here. Okay, maksudnya first you kena faham lah, the whole process of the system is like this. From the input, will be send the component to the test station, and once the test is done, then you need to send back the component, the tested component, back to the output conveyor. So it's mentioned here that when a component is to be transferred to the output lower conveyor, the cylinder is to be retracted. Okay? Maksudnya untuk sambungkan jambatan ni, bridge ni daripada test station kepada output conveyor, of course you kena turunkan jambatan ni ke bawah kan. So untuk turun dia kena cylinder mesti retract. Okay? So cylinder retract and by actuation of push button. Okay, so this is also very super important because it mentioned that the cylinder must retract by activating the push button. Okay, you cannot use other button, only push button because it's already mentioned in the question. Okay, and then once the component has been transferred to the lower conveyor, the cylinder is to extend again automatically. This is also important. Okay, automatically and ready for transferring the next component. So by this point now, the cylinder is back to the original position, and then you have to repeat the same procedure again for the next component. Okay, so the question asks you to design both pneumatic and electric circuit. So let's try to solve this question. I just draw it on the notepad to make it quicker instead of using FleetSim. So macam mana? Sekejap. Maybe keep. Okay. Okay. Sebelah. I hope you can read this. Okay. So, ni notepad. Silap. Should be pen. Pen, draw, basket. Okay. So let's solve this. So you know that you have to design first the pneumatic circuit and then electric circuit. Okay, in this case, maybe I want to change the question a bit. I want to say that the conveyor transfer. So I want to specify the type of cylinder by using a double acting cylinder. Okay, so yang ni pun you kena penting juga, you kena highlight. Okay. So please take note that I have changed the question so that I can, so that because in your task 1 in task number 1 you have to use single acting kan, single acting. So now for this example I want to specify it to be double acting lah. Okay, double acting. Okay, so you know that you have to use double acting. So what you can do first, you draw lah double acting cylinder. So this is your double acting cylinder. And when you draw, you have to remember that the question says that the cylinder will normally be in an extended condition. Maksudnya bila you lukis ni, you terus letakkan piston ni dekat hujung macam ni. Okay, and then it never specify what type of DCV. But you know that when you learn in the lecture, when you have a double acting cylinder, you can use either 4-2 ataupun 5-2 DCV, right? Okay. So in this case, I choose to use 4-2. So I just draw first 4-2. Okay. And then, cantik. I can draw this faster on the whiteboard, but not here in this case. Mungkin besar sikit. Okay, so you ada 4-2 DCV, kita pakai yang ni 4-2. But now kita tak tahu lagi nak pakai apa, nak pakai actuator apa kan, solenoid ke push button ke, itu bergantung pada soalan lah. Okay, so dia cakap the cylinder must be cylinder to be retracted by actuation of push button. So In this case ada dua solution So dekat sini dia bagi tahu push button, tapi dia tak bagi tahu yang push button ni sama ada push button dekat dalam electric circuit ataupun push button dekat DCV. So I will show you both solution but solution 1 I will consider that the push button here is this push button, the one that you have in in electric circuit later. So therefore, what I can do here, since I need to control the since we are going to use electric circuit later, so I have to this DCV must have both to be actuated by solenoid. Okay. And then in the original position, the cylinder is extended, so I just connect to this position. This one, and then, right? And then don't forget, you have to have the compressor and also the exhaust, okay? So that's all for your pneumatic circuit, because it never mentioned about any you have to control the speed or whatever, no. Okay, so that's all. So now let's try to draw the electric circuit diagram. So for electric circuit diagram, of course you have to have the power supply lah. So normally 24 volt, kemudian you ada ground lah, okay, ataupun zero lah. Okay. So now I want to choose to use this push button as what specified in the question. So I draw this push button. And when I push this push button, what happened to the cylinder? The cylinder should, as what mentioned in the question here, cylinder is to be retracted by actuation of push button. So when I push this push button, I have to change the DCV so that the DCV will be in this position. Let's say I give it this as solenoid B, and this is solenoid A. Okay, in order for cylinder to retract, we have to activate solenoid B. So I know that when I press push button, at some point, by any means, solenoid B must be energized. So I decided to use indirect control, where I will choose to use this coil, relay coil. So I just name this as K1, and then just connect to ground lah. So when I have this K1, so K1 should have a contact, so this is my contact K1. And this K1, I connect with my solenoid. And this is my solenoid B in this case. Okay. So now our solution is partly complete, but it's not completely complete yet, because now we just managed to retract the cylinder. But how to bring back the bridge up? Because that's what mentioned here. The cylinder is to extend again automatically. Okay. Since the cylinder must extend automatically, the term automatically here shows that you must have a sensor where you will put the sensor in the real application here. You have to put the sensor somewhere okay, so you have to put the sensor here. Maknanya sensor ni nak detect bila cylinder tu bila you tekan push button, cylinder piston akan retract kan. So bila piston retract, kita nak detect sensor dekat sini, kita letak sini S2. Inilah. Okay. So bila silinder ni retract, kita nak detect dia punya end position ni. Okay. So bila silinder retract, S2 ni end positionnya ni dia akan bergerak dan S2 ni akan activate dan S2 ni akan make sure that silinder tu extend semula. Okay. So apa yang boleh kita buat kat sini, kita tambah sensor S2, sensor yang sama, cuma simbol dia lain lah. Kita guna normally open S2, and then this S2 must be at some point energized solenoid A. So I guna indirect control sekali lagi, so I guna K coil, it's my K2, and then then this K2 must be connected to solenoid A. Alright. So now, after you finish drawing, you can try to double check. Always you have to double check so that you are answering all the requirements. So you can see again. So now the cylinder is in the extend position originally, and then when you press, boleh tukar warna tak? Color. Oh, boleh. Okay. So bila you tekan push button, so ni saya label lah push button. Okay, so bila you tekan push button, K1 akan energize, yang ni akan tutup. Okay, K1 akan tutup. So B akan energize. So bila B energize, solenoid yang ni akan energize, dan you kena bayangkan lah, saya tak boleh nak lukis kat sini. So you boleh bayangkan yang bila B activate, position yang ni akan aktif. Maknanya sambungan ni akan berlaku kat sini lah. So maknanya silinder akan retract daripada sini, sambung ke sini, kemudian daripada sini, okay. Maknanya sekarang awak punya pneumatic compressor dah sambung ke bahagian B kan. So sini masuk ke belah kanan, silinder akan retract dan keluar masuk ke exhaust. Okay. Kemudian bila end piston sampai dekat sini, sensor 2 akan detect. So awak punya sensor kat sini awak pakai normally open. Maksudnya bila dia detect kat sini, yang normally open ni akan close. Okay. Tapi maksudnya awak dah lepaskanlah push button ni. Sebab ni push button sahaja, dia bukannya detent switch. Awak tekan sekejap dia, awak kena lepaskanlah. So bila awak dah lepaskan push button, dalam masa yang sama sensor ni detect piston punya position, end position. So K2 akan energize, K2 akan tutup, dan A akan energize, dan solenoid A akan energize, dan sekarang ni position yang ni pula yang akan aktif. So silinder akan extend semula. So bila silinder extend semula, sensor ni dah tak akan detect lagi position, end position tu. So sensor ni pun akan open balik. So K2 ni dah tak energize lah. Sebab masa ni K1 yang energize. Ada soalan tak? Any part that you don't understand?
Tak ada sir, tak ada.
Okay, semua tak sabar nak buat lab, saya tahu. Okay.
Excuse me, sir.
Yes.
I want to ask a question. Kenapa tak terus sambung push button dengan relay solenoid tu?
Boleh je nak sambung, tapi kalau you tengok dalam nota sebelum ni kan kita ada, kalau you sambung terus, you punya circuit function juga kan, maknanya macam ni you terus sambung solenoid kat sini kan. Itu adalah direct control lah. Cuma kalau you baca dalam Direct control, apa beza dia kejap kat mana direct control. Inilah beza dia kan. Bukan. Ini untuk ni. Yang you masukkan yang macam ni lah kan. You terus sambung ke solenoid kan. So ini adalah direct control lah. Sama je dia punya the operation will still result the same operation. But the one that I use is this one because you can see in the real application so kita biasanya dalam industri kalau kita dapat soalan yang macam ni, yang the actual question like this, which is the one that being used in the actual application, in this case Newton conveyor kan. So we should consider kita consider dia sebagai application yang kompleks lah. So in practical, it is more to be honest, it is more practical to use indirect control. Okay, it is more practical, but I don't say that this is when you use direct is wrong. In theory, it's still correct. So in exam, because if you are answering on a paper, it's still correct, but you just have to think in the real application, especially when we have this kind of the situation given to you is actually the actual situation happening in the real industry. So that's why it would be better for you to, especially for your mini project, because you have to consider the actual application in the real world, right? So you should consider indirect control lah. But I will still accept. Okay, I can still accept if you give me the answer by using indirect control, unless the question say that you have to use indirect control. For example, like this, design both magnetic and electric control to meet this requirement. Contohnya macam ni lah cakap, okay, by applying indirect control. Kalau macam ni, then there will be only one answer, which is using this one. Okay, but originally just now we don't have the question doesn't say anything, so it's up to you. You can choose by either using direct control or indirect control. Okay. Back to the same question. I think this example is not very complete because it doesn't mention about the push button tadi. It's quite confusing because it just mentioned about push button. So you can see that in your you ada dua push button dalam kalau case ni, you ada push button, kalau you tengok dalam DCV you ada push button ini kan. So you ada push button dekat DCV, and then you ada juga push button dekat electric circuit yang pakai sekarang lah. So let's say, since this question is not very specific, so let's say I want to solve this again by considering that the push button in this case is the push button at DCV. So now my drawing will be a bit different. The rest is just the same, but my DCV will be like this. Alamak, merah pula. Let's draw with different color, blue. Okay, so then my DCV will be like this lah. The same type of DCV, still 4-2. But now I change because from my definition of the push button from the question, I think that it means push button on the CV. So maknanya I akan ada satu solenoid je kat sini. So this is something similar to your task number 1. If you remember, task number 1 you have to be actuated by hand lever kan. Kemudian baru you ada sensor. So I just replace this with this, and then your circuit also will be different. In this case, you will only have the sensor S1, and then K2, and then contact K2, and then I have this solenoid A. Okay, so if I define this push button as the push button at the DCV, then this will be my answer. So means that when I press push button here, merah. Okay, so when I press this push button, no. Boleh tekan push button. Okay, cylinder to be retracted by action push button. So yang ni salah sebab yang ni extend. So padam. So kat sini kedudukan push button tu salah kat sini. So in this case, push button must be this side. And then this is my solenoid. Okay, so let's try simulate again. When I press push button, cylinder akan cylinder akan retract. Okay, betul, cylinder akan retract. Kemudian bila sensor detect position piston, so sensor akan tutup, K2 akan tutup, so yang ni K2 dan A akan energize. So bila A energize, cylinder akan extend semula. Okay, so you can see how we can have two different solutions depending on how do you define this push button. Okay. So in this case, I would say that the push button at the electrical push button. Kalau I beritahu electrical push button, then the solution will be this one lah, yang atas ni. Okay. Tapi untuk task